The title of this section is What is the State of Android on RISC-V? Yuning Liang will be talking to us. He's the founder and CEO of Deep Computing, and you can find Deep Computing at deepcomputing.io. So, over to you, Yuning.
Hello. Hi, everyone. Can anyone hear me?
I can hear you.
Okay. Oh, good. So,
Yep.
yeah, I just, yeah, good. And me just, I found it deep computing during the COVID and got nothing better to do when I was in Shenzhen and Hong Kong and only hardware. I'm a software guy, so it's in Shenzhen you only do hardware. So and when I looking back, just I spoke to Chris uh, for an hour. And looking back, I was work for Xerox. I got to know Chris. And looking back the past 20 years, I will see that it. I don't see myself a choice in not doing RISC-V. Seems everything is preset and making me work on it. For 20 years, I was working on a very closed system company from Xerox, have everything themselves. And then to Nokia, have everything themselves. And then for Samsung, same. And then Huawei, same. So a very close source of my career. And then I start working on RISC-V because my previous software startup was based on MIPS compiler, very famous compiler called Open64, one of the best compiler before LLVM. And a matter of fact that compiler dies because it's not open source enough, fast enough. Back in the SGI and MIPS day. And then LVM got open source, got the community support, and then get everybody on it, and then people learn far better, far faster. So, and then because of that compiler, because it's good in technology, I use it to make it as a whole program analysis backdoor of all the software programs. And then COVID comes, and then and can't do any 2B business. Then I start working on RISC-V, and because that compiler is RISC-V, originally I think, oh, why not I make a compiler to support RISC-V? And because the benchmark is very good. So far, we beat any of the LVM benchmark on RISC-V because no one working on RISC-V LVM optimization fast enough yet. So it just like that. So and because I try to sell my compiler to all the SoC guy for RISC-V, they saying they can't even sell their chips. And can you help me to sell my chip before I buy your compiler? And then I say, oh my God, I'm in Shenzhen, so okay, why not I use your chip to make something out of it, you know? And lucky enough, because sometimes I will find that uh, whoever supports you will lead you somewhere somewhere new. So that my startup, one of my startup, the first customer, biggest customer is called Allwinner. So the Allwinner founder support me to use the tools and to find their bugs on their software. And then he helped me to find out. And one day he retired from the Allwinner, and then he asking me what should we do about RISC-V. And then I say, hey, somebody telling me they can't sell their chips. Can you help me to make some ball with that as the RISC-V SoC? And then say, yeah, I got a lot of friends who make a lot of money from me, and I'm sure they will help you. And then one of the guy, the factory, they make we call OEM laptops for Nokia and for a lot of other firm as well. And he said, "Oh yeah, okay. You can use whatever I have, the factory, the R&D, blah blah blah, and give me a chip, give a schematic. We can help you to make the ball, and then you can use everything else." So that is come to me. Deep computing is fun, and then first product is to make RISC-V laptops. And then, because I had no idea about making laptop, if I am a hardware guy, probably already turn my head and never do it. I was so stupid, you know. But in COVID, I got nothing better to do anyway. So no one have a good thing to do. So and then we lock down in the city. The city can still move around, but you just can't get out. And then we look at, okay, and then we give a chip to the factory. They say, I don't know how to make a motherboard. We don't even know how to make a schematic based on your chip. Don't just give me a chip. You need to give me the whole solution, same as Intel, the turnkey solution with all the schematic, with all the basic layout, with all the we call it AVL, approved vendor list components, and then you just had to lay out a little bit and fit it into your laptop chassis, and that's what they do. And I start understand. Oh my God! If I want to make a motherboard, I had to learn everything how to use this chip, and that chip was pretty good. It's a 12 nanometer, first RISC-V 12 nanometer, 4 core, with quite good imagination GPU as well, and that we found it deep computing. And then I use that chip. That is a test chip. So I make a few laptops and samples. And also I ported the first Android on it. We know Android is important, so that's why I'm here. So if anyone interested on any RISC-V device, go on to deep computing and ask Google or ChatGPT, and you guys will find all I'm doing just for RISC-V, and losing a lot of money, but I keep doing until and it go up to 10,000 volume. And that's myself deep computing, and and as I said before, I for the past 20 years I work on closed system companies. None of them like open source or contribute back to open source. And I suddenly moved to a very extreme in RISC-V. And even some of those guys open up the CPU IP from 32-bit to 64-bit. Now our record is even high school can do a 32-bit CPU themselves on the FPGA. Pretty amazing. And that FPGA up to a pretty good speed, you know. So it's very different.
Okay.
And when we now on to getting RISC-V up to ARM stage, I would say that now the A core we got our AIPC, that chip, it is pretty similar to what I just joined Huawei 10 years ago. It's very similar to A72 performance, but everything else is bad, especially software, from the toolchain compiler and Linux kernel, blah, 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 a lot of things. It's just not good enough. The hardware is there. That's why I'm a software guy. I'm lucky I'm a software guy. So I got to know Chris. I got to know a lot in this guy. And then we start trying to persuade people, all the open source community now should fall onto RISC-V and contribute to it. And looking at RISC-V just like 30 years ago's Linux, you know, for at that time we're young. Now we're all old, right? Chris, you retired, half retired. I'm close to retired. If I can get RISC-V off the floor last year or the year after, then I retired. I've done my job. So and just like from Unix back to Linux. Now I think and RISC-V compared to RISC-V and ARM, they're very simple. They're very similar. It's just like ARM had to go high end, make more money, and then they don't do any low end stuff or do properly support enough. And they're gonna shrink the resource onto the low end stuff. And then RISC-V going to take that and then take that approach. And also we're using new technology to make sure that RISC-V makes a chip far cheaper than ARM.
So Yuning, so at that, so with decomputing at the moment, then you have the laptop, the
Yep.
Roma, is it called?
Yep.
And then I guess that's doing quite well. So that is basically running a Debian version. Is that correct?
No, now we got Ubuntu to support it. So
Okay,
basically,
Ubuntu.
all our product will have vendor kernel Ubuntu
Okay.
and Fedora as well. Fedora Remix and Debian, of course, we run on it. And but not out of the box because Debian we got a lot of complaint and Debian comes in the new version. Why doesn't just run on it? Because all our SOC is not done all properly upstreaming, and we still have to use vendor kernels.
Okay,
So
right.
yeah, but
Which is a pain.
we're going to sort it out. And also, I make two generation pad. One is 4 core, one is 8 core. So and we did port on it, one or the Android port on it, and they both run except GPU. We have a lot of headwind on the GPU. The
And
GPU,
that's
yeah,
an Imagination Tech GPU, as we were
that's
discussing.
Imagination Tech GPU, and Imagination. How Imagination make money? The business model is because they sell Linux SDK and Android SDK. So I bet the chicken and egg. All right, and I think for one of the test chip from Alibaba T-Head, they go TH1 by 20 the test chip, and they did bought the Android SDK. So that's why we did the first port on it. The Android 10, Android 12, even Android 14 is working on it, right? And just for that particular IP with on that particular chip. And after that, none of the other SoC bought the Android SDK, and none of the other SoC that can afford to hire us to do the port for it.
Okay. So you have to do it each time for each new software release. Essentially, you have to do a new port.
Yep. And the other thing is that because just doesn't want to limit, I thought we did 3 port on it, and then and they don't open it up because to Android port, not just a few things. A lot of TD jobs, all the system side, device side, and then all the driver side. Basically, Android. One of the problem of Android on RISC-V that there's no porting guide. Right? For us, 2-3 times is very quick. You know what to do. But if for probably even all of us here, if you don't have a porting guide, you don't even know where to start on this 50 gig source code, right? So that is something that I was raised to the RISC-V community. We should be able, has to be open it up. So that's why I will be talking about it in FOSDEM. I won't be talking about in the LPC. In the Linux Plum conference in Tokyo, I will be there. I will be talking about how do we do kernel upstreaming for RISC-V, pre-silicon upstreaming. Before the chip comes back, we finish the upstreaming except GPU. So it's a big leap forward. And then in FOSDEM, I'm going to talk about how we're going to share all these on Android porting. So basically,
So what's the big idea?
yeah. So basically, I will do another port, a fresh port, on our new 16-core chip with an external GPU. So I teach you everyone how to port to do a reference port, and then let you guys more contribute to make that port more I would say more solid.
Okay.
And because I have limited resources, I only can do a reference port and manage to can see the screen, see the app, run the app. We won't be able to port everything on the Wi-Fi driver, audio driver, Bluetooth driver, all these things and link it up. So that we was going to do on the on FOSDEM. So that's why we pushing. And then next year will be very interesting. And then you guys definitely can help us on us. And then whoever help us, you might be able to get our hardware support for free.
So you see this as a community approach.
Yep. Because the reason being is because even uh, I think the Google guy trying their best to get resource out of the management, because now everybody in AI, even Android is shrinking, the resource is shrinking. We don't blame them, right? Now we need to ask for the community here. Here, everybody here and there give me a day, a week, and then helping up. And all I had to do is that probably Chris can facilitate that. I can facilitate all the hardware. And then I can facilitate all the foundation port, and I can facilitate all the kernel driver. I can facilitate anything. And then you guys can build on top of it, make a proper AOSP RISC-V and mass close to mass production qualities. Instead of now, whatever the port I do, it's just a toy quality. You know what toy means, right? It's everything, every now and then you crash, any app doesn't work, all these things. So that is the state. The state of AOSP is that you can get an emulator works and we cut a fish, but you won't be able to quite easy to port to a new SoC or a new platform aboard. But we're going to fix that in next year.
Okay.
So, I'm sure that Google will give us support then, and hopefully they will accept our, we call it the reference implementation of SoC with an external GPU. But the internal GPU is too hard to solve for me for the moment. So, and then move forward, I think it's definitely, so everything is going to be RVA23. And
Okay.
all the old chip is going to be dead very soon. So, and sorry about that. And people already wasted probably $1 billion on it already.
So RVA, that's the ABI standard for RISC-V. So
It
currently, I
basically
think most hardware is RVA 22. Is that right?
RVA22, RVA20.
Or 20 even? Okay.
So,
But RVA 23 is the preferred ABI because it has virtualization for hypervisors and vectorization. Is that correct?
yep. So that will be the first thing, and you guys will be, if lucky enough, you guys will be seeing it in the FOSDEM of the whole new ball with the 16 core RV23 SoC on it.
Okay, that'd be cool.
With if before the DDR saga, now the DDR has gone up 5 times price now. You otherwise you will be seeing 64 gig there other than 16 or 32 gig.
So just to step back a little bit. So when do you think RVA 23 hardware will be available?
January
January. Fantastic.
from us. Yeah.
January 26.
Yeah. So if whoever that from I think that's why I said I'm thinking that now AOSP for RISC-V has to become a community project instead of Google project. So
Okay.
either fork or either continuous sync approach. Right. And because it's just no one has good enough resources. Right. And I do explain to the whole market saying that, right, how Android works. So Google spent a lot of effort on the reference implementation on ARM, like, and then they mass produce that baseline on Pixel, on Qualcomm CPU or their own CPU. That's for ARM. But no one doing it for RISC-V, right? So no one gonna do Google's job on RISC-V. And plus that, like Qualcomm, they spend a lot of resource, MTK, MediaTek, or Rockchip. They spend a lot of effort on producing a turnkey solution of Android devices. Over over 100 engineer on it. There's no one like RISC-V can afford that luxury either. So that's why. And then the other thing is that like all the product company, like whoever makes tablet or mobile phone like Xiaomi, Huawei, OV, Samsung, they put a lot of effort on making the Android device, end user device. So you can see the whole ARM resource side, they are probably 50 times more resource than RISC-V. So for RISC-V to mass produce on its own by its member company, I would consider mission impossible. We had to turn this back to the community side and hope the community side have 100 and 200 and 1,000 people and all the young kids learning porting Android, learning making new API for automotive, whatever, learning porting a new ISA, and hopefully that we get a reasonable, good, motivated engineer, and also, and you guys here, and all very experienced Android. All we had to do, like me, deep computing or RISC-V member, just need to facilitate all the hardware to you guys, and I'm sure you guys can contribute. So that is the side. I was saying back to Chris' question about when become the mass produced quality. That means you have to implement all the how interfaces. I was saying that most of the except GPU, everything very similar to ARM because RISC-V SoC will use as many IP as the ARM SoC. So if you make Android tablet and with ARM or with SoC, I would say the main difference might be just the main CPU. The rest of them, I'm sure they already have Android drivers. You can reference. But the point is, those driver is closed source to into those either the product company like Xiaomi or Samsung or whatever. Is or with the chipset guy if they don't open it up.
Yeah.
Right? I was saying that they're relatively easy to port.
Okay.
And except GPU.
So
GPU, I was saying it's all about money, about whether chicken and egg, which side we deal with it. I was saying that let's deal with anything else first beside the GPU, and then GPU will get it done a matter of time.
So So first of all, then we would need some hardware. So you say that there'll be RISC-V chips, RVA 23 early next year. How long would it take to get development boards based on that chip?
I would say that we roll out. The problem with me, right? I'm a software guy. I hate touching dev board.
Okay.
I'm not a hardware guy. I'm not building all this. So I would say that you guys will get my motherboard for framework faster, and then you guys can start putting Android on it. And I'm sure that we can use the M.2 connector to connect it to connect external GPU.
Okay. You didn't mention this, but Deep Computing also do this motherboard for the framework laptop.
Yep. And I tell
So
you,
do you want to talk a little bit about that a bit?
Yeah, I probably elaborate a little bit about it. And that's back to this discussion with Chris just 1 hour ago. And I was saying that before I do 2 laptop myself, I use my factory shareholders facility to reuse the laptop shell chassis, but making the motherboard for that it's not difficult. The difficult bit is what? Because I roll out every 6 months 1 new motherboard, RISC-V motherboard. And then, for example, like Chris, if he bought my first generation of laptop, he won't be able to replace the motherboard himself. So that is causing me headache, really headache, right? Because I know the pace of RISC-V going very fast. With from 4 core to 8 core to 16 core to 40 core, whatever, it's very fast. Every 6 months you have a new motherboard. So and one of my good friends, and if people can Google RISC-V Summit 2024. um, back in 2023, and the first, I think, is it 2004, 24? Yeah, around there. I can't remember too old. And my good friend saying that seeing me making the laptop and then waste all the effort, and he got one, he can't upgrade his board, he's screaming at me, and then he say, you should not do that anymore. Don't do your own laptop. I said, what can I do? Right? I say, do you know about frameworks? I had no idea. Come on. Back in 2024, earlier, I had no idea about framework. Coolest, right? And then he said, and I look it up. I paid enough on Twitter at the time, and it's not even X yet. And he talked about what his vision on framework. He's about opening up the laptop back to, back in the old days, Chris, do you have a IBM? We can swap the CD-ROM to a floppy drive and take the battery out, comes another battery, and pull the the PCM CIA car. Do you remember all the old days?
I've got one in my cupboard somewhere.
That's it. That's it. Nina say, I'm going to move back to that way. The reason being is that it's the vertical about optimize everything for the profit. And when you open it up, it's all about a lot more people crazy enough to pay around it. And you don't earn money from the base, but you earn money from people making crazy things, the accessory for it.
Okay.
That is the idea. Basically, it's just like from a very close MacBook approach back to IBM PC. Remember we call it IBM PC? People can just play and play. Then you have a PC ecosystem. We move back to that way. And then I say, and funny enough, remember that time Trump test, whatever test, when it come crazy, you know that, right? And we just realized that the whole world except China can make laptop now. It's ridiculous. I moved back to Europe. There's no laptop factory in Europe. I remember I was shocked, Chris. I was from Xerox. We can make everybody thing in England. And then I'm from Nokia. We can make everything in Nokia house in Farnborough. And by the time I moved back to Europe, I said, we can't make it anymore. And then I was so pissed off, Right, really pissed off. And then I take the idea of framework saying that, come on, we like this modular approach. That means I can make any part as long as, because there's no assembly line anymore. Right, Chris, I can send you a whole set of framework. You had to body assemble yourself. Just like you buying things in IKEA, a furniture, you assemble yourself.
Okay, so the framework becomes the module to carry the whole thing, and then you just plug in a RISC-V motherboard, and away you go. That sounds cool.
And also you can upgrade it. And also I don't, I was a little bit annoyed, very annoyed, or in English term, I'm very pissed off. A lot of RISC-V guys say, oh, I had to do my job. I can't use RISC-V. I have to use x86. I would say, what the hell, right? And you try to make money out of RISC-V, but spend money on x86. You telling me that, right?
Yeah, it's crazy.
Then I would say that you'll never be able to know all the RISC-V problem if you don't bother use it.
Dog fooding.
Yep, dog fooding. So, and framework, give them now. You give a laptop, you can have a x86, you can have ARM, you can have Windows on it, you can have x86 and RISC-V. You don't have excuses anymore. If you want to do your job on x86, come on, change the motherboard. If you want to play around knowing the RISC-V program, change the RISC-V program.
Okay.
So that is the state of why I choose framework, because it's open, open modular, same as RISC-V. The vision are the same, and then same as Linux, vision the same. So
Okay.
that's it. And then back to the port, the Android RISC-V port. Once we open it up, where should we open it up? And then Google gonna review it, and we take apart which one they take, which one they don't. We have to fork it or sync to the latest AOSP. And then if people needs NTK, we will produce the NTK, and we will produce the SDK as well, so people can develop anything that runs on the external GPU. So next year I'm gonna fix all these problems and lay out the foundation that the whole world open source world can help us on RISC-V, other than we spend our own time and money on it.
Okay, that's cool. So can I?
Asking tablet, I see a question asking tablet. Tablet is easy to do, except the GPU. The GPU, I cannot resolve that crap shit. And on apart from that, if you're using external GPU connect to a screen, and you're good enough to do a tablet very easy. And then smartphone, no, I can't do it. I don't know about Chris. In Nokia, we have a fight against Qualcomm. And then back in Huawei, I have another fight against Qualcomm. And I'm not gonna make a smartphone again to have another fight against Qualcomm. I can't, because Qualcomm is not just a commercial company. It's somebody have a very military power guy behind it. So we all know. That's why there's no privacy in Europe, because we lose all the modem capability. When I back in Nokia, we have all the modem capabilities, but we lose all of them.
Okay. So does anybody out there have any questions for Yuning? So there's a lot of interesting things that we've gone through in the last 25, 30 minutes. What do you think? Who's out? Who wants to do RISC-V?
Raise your hand.
Raise your
If
hand.
you're hardware, and you have to contribute your life and blood. Same as me. Amen. Good.
Okay, I'm seeing some hands raised. Okay, so what do we do? And how do we synchronize all this with the stuff that Google did? I mean, Google have done some basic support.
You cut the fish with an emulator. That's first thing, and then I'm going to do a reference implementation on RISC-V. For example, a chip, a real chip. Then I'll fix all the device target and blah 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 blah, everything, and the whole patch, and we'll work on the latest Android 16.
Okay. Ahmed Fadi, have you raised your hand?
A lot of people raise
Maybe
their
not.
hands. Yes, somebody or John Hans.
Okay, I thought somebody wanted to ask a question there. Go ahead.
Hello?
Hello?
Can you hear me, guys?
Yep.
It's a very interesting topic, especially for architecture RISC-V. As far as I know, Google spent a lot on that, but somehow they changed the focus to virtualization and some other stuff. My question is about security component, this ARM trusted execution environment. Is there alternative for RISC-V architecture? because we have key master and gatekeeper are crucial, and they are mandatory to put up Android, except if we use software encryption. I just like it get into my mind this question, but yeah. So this is my question about the security alternative for ARM class execution environment.
And let me get to it. Yeah, because Android, before they move to mass production, there's no security need. So basically, RISC-V is not, as I said before, the port on AOSP is not ready for mass produce, not ready for end user. So we probably the security bit will be the last thing we're going to tackle. But I do not see any major problem because most of the chip RISC-V they reuse all the ARM SoC security stuff. So it's a matter of porting. But because now the AOSP we're going to do is more focused on developer to mature the AOSP for RISC-V. So we will not consider putting a lot of major effort on the security side. I don't even bother doing secure boot because we just need people to help us to easier instead get over all the hoop of freshen the hardware.
Yeah. Thank you for that. Yeah, this. I think actually Google also when they created this RISC-V for cuttlefish, they used software encryption kind of this key master software. But yeah, that's true because also I asked about TEE because it's a kind of ARM flavor, let's say. So even for the SoC vendor, they just get precompiled binaries for those, and yeah, so it's a bit closed. So that's what I'm asking about.
Oh, RISC-V everything will be open source.
Yeah, that's really nice.
So if someone that opens the open source up, because most of their SoC guy, they need deep computing to first launch the beta on their chip. They had to listen to me.
Okay,
So
sounds good.
and also, I think people join RISC-V, they are more open than ARM guys. They're willing to open things up because there's no competitor, because there's no market.
Yeah, that's good. That's nice.
Yeah, that's the nice to us, the software guys realize because everything open up because they need your help, they need our help to use their stuff to ramp up the volumes. It's very different from ARM. ARM doesn't need any of us to mass produce their chips because everything's there. So they don't need to open anything up. They can't even bother to upstreaming.
That's true. Okay. So I think this is sounds quite exciting. I like the idea of kind of a guerrilla campaign to make RISC-V the new standard and to make it an open standard with open source software driving the whole thing.
Yeah.
Sounds cool.
And you will, if I can sort it out the GPU, then you will see that you have open source GPU, open source GPU. TEE is easy to do. Secure element is no brainer to do, and then everything will be open up. And then you past that you have framework. Everything's modularized, open up. Anything can design accessory for framework. You have all the CAD, 3D CAD, and then everything's open it up. That would be part of very amazing world, you know. Everyone can make a framework laptop at home.
Okay.
3D printing, you know. Get the parts around the world, you know, Doesn't need to relying on a assembly line back in the Far East. Not at all.
So looking, you mentioned GPU quite a few times there. How could we resolve the GPU problem? So the problem is basically is that there isn't a suitable open source. Sorry, there isn't the IP for a GPU with open source drivers. So as we said, everybody tends to use Imagination because they're one of the few vendors that can do this. What do you do? Can we make an open source GPU? I'm guessing not. That's kind of tricky.
I would say same as one of the RISC-V IP guy. They just takes up, and then one of the startup bought all their hardware IP, software IP, and open source it. Then you will see that you will see the open source AI NPU version. So once that this path going down, then we wait for Imagination go takes up. So basically, we still need to, because this is a legacy business model, legacy share structure, and then Imagination, even the management can do nothing about it, and then it's very difficult. And we did open source GPU, which people have a vision on that, and so far none. Even the richest guy in the world, Jensen Huang, have no vision on it. He believes closed software. He doesn't believe open source.
No, probably because he's a hardware guy. As we said earlier, hardware guys don't really get open source.
I think will take me a while to understand. Open source is not about technology.
Absolutely.
It's about civilizations. Just like the kids, we open it up ourselves, and just like our teacher open up themselves in the school, teaching people, make a better human. How people doesn't understand that. But anyway, and one last guy we can need to convince Elon Musk.
Why?
He's rich enough to, if he open source up SpaceX, he's open source up Tesla, he's open up Optimus, and I'm sure he has the power to buy one and open source it up. And look for
interesting. I mean, but Tesla isn't open source. The operating system
is claim open source. The whole car is open source. They say they claim, but I never get access to it, so I don't know. Next time when I see him, I might ask.
Absolutely. I'm not convinced that the software on the Tesla is, just on the head unit even is particularly open. But I could be wrong. I've not tried hacking it.
Yeah, indeed. There's not on the Tesla side. It's not open source.
Yeah, but
I don't know now. For the infotainment, I don't know whether they're on AMD.
They're using AMD chips at the moment. Yeah.
Yeah.
They started off with the Qualcomm. No, they started with NVIDIA Jetsons, I think.
Yeah. And AMD, yeah, and now I'm not sure their own chip already doing the infotainment already. I don't know the AI chip they use. I'm sure that you won't see Linux kernel driver for that. So basically, we don't see any hacker around hacking the Tesla chips. I still remember Yellow Dog running on PlayStation, PS2, PS3, the Cell CPU. I think we need some game people have drive to hack around.
Cool. So there's a question in the chat. So Marcus says, is there any real interest or future in very GPU?
Nope.
Okay.
The
So-
reason being is that rare GPU is not mass-produced product, and no one can take the risk. And as I said to Chris, and in China already brutal enough, still needs 30 millions on the SoC, and they could not afford to make a mistake on a long mass-produced use GPU IP.
Okay. So sorry, it takes 30 million to create a new SoC?
Yeah.
Okay.
So we call it $30 million questions.
Okay, I see the problem.
But our target, probably by 10 years time, we will drop down to $10 million. Then that means that, and if $10 million, if the chip is around $50, then you just need 200,000. Then you can earn you can break even. That will be the time everybody can make their own chip.
Okay.
Very interesting.
Just to bring it round to one final question that I'd like to bring up then. So for Android really is a smartphone operating system. Will there ever be smartphones based on RISC-V? Because that would be the biggest.
I would say it's because the modem. And when I was at Nokia, we beat Moto so badly because Moto, from analog to digital, they cannot turn their head around. And we got beaten in Nokia after GSM. We got beaten so badly by Qualcomm. We don't believe high speed is necessary on mobile. We lost so badly on the LTE. We lose the battle on LTE. That's the side that we and Europe having a wrong back on the mobile. And yeah, then now it's one monopoly. And when I was in Huawei hired me back and start working on the modem. I think you had to do it. And you are the one of the biggest market. You have to have your own modem. And then that's why the sanction comes. Sad news, but I know that's human, man. So no one allowed to touch telecoms unless you are military power enough.
So Intel had, well, again, Intel spent billions of dollars on their own modem based on Infineon, I think.
I got all the stories.
They kind of had it working, and then they gave up.
I tell you why they gave up.
Go on.
I have all the story about Infineon. When I was Nokia, so I remember we do a course down chips and based on Infineon, and they just can't deal with it. They just can't compete. And because you're from Siemens, and then you have a joint venture to Infineon, and then you have so many product line, and you have no focus on a massive invest capital. You know, modem is a very, I call it resource intensive business. I give you an example. In Huawei, in Nokia, our modem guys, we have more modem guys than anyone else because you had to have we call it CSL layer, You're the compatible, and then you're 2G, you 2.5G, GSM, blah, 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 blah. Basically, you need to have a team that have 30 years experience to pass the certification, to implement all the spec, and pass the compliance and certifications. And no one, no, if you're newly formed startup or company, there's no chance, zero chance. Until Apple. How long people took Apple to do it?
About 5 years.
After they bought Intel's analog side and left the data, I think Intel still keep the data side of Infineon, data modem side. And the analog side is sold to Apple. Took how long? Oh my God! I think it would be 10 years. I don't know. Now Apple is managed to crack it. Right. So, and I don't see any European company gonna have the resource to do it anymore, because we don't have the LTE expertise and the 5G expertise anymore. The only hope I would say for RISC-V, we go on satellite, Starlink. Everything's go on data modems. So that is my hope. Otherwise, we still have to use Qualcomm or Qualcomm IP external modem, which is not effective enough at all. So that's my question to mobile phone. Don't make me make another mobile phone. I've done Nokia, I've done Huawei. I don't want to do it again myself. I don't want to manage 5,000 people and go around 200 countries. Each country have 5 operators. They're gonna kill me.
Okay. So I'd like to do a wrap up on this. So thank you very much, Yuning. That was a fascinating look at the state of RISC-V and what needs to be done to make RISC-V viable, particularly with an running Android, maybe on tablets, maybe on phones if somebody can solve the GPU and the modem problems.
Might be on TV. Might be on TV.
TV would be good, yes.
Might be on set-top box. Those might be, anything without the modem might be the easier thing to crack.
Yeah, that would work. Maybe automotive, although there is... So just going off a slight tangent. So automotive does have modems, of course, but they tend to be separate hardware.
External modem, yeah.
Yeah, so they have the telematics box.
Yeah, they call T-box, right?
Yeah, and that's where the modem is. So as a separate thing. So it could work in automotive as well.
It could. Yeah. And the only thing left is the apps ecosystem. That means outside of China, we need Google Play, which I do not think they are going to do that.
In China?
No, in outside of China.
We'll see. There's a big debate as to whether...
The App Store had to produce 2 binary. One is RISC-V, one is... Unless they start moving on to big code, same as Apple. So they host one big code, and then when the device start putting down, they compile the big code, becomes the app, and then install the device.
Okay. Anyhow, like I said, I'd like to draw this to a close. So that's been fantastic. Anybody that has any questions, post them here in the Meet, or follow up through either the Meetup app, or contact us on aospdevs.org and contact us on our Discord server there. That's probably the best way to get hold of as many people as possible.